This is the video for the max K cover problem, or the max coverage problem, or the max K coverage problem. So click on max K cover. Okay, so the setup here is that the input data is very similar. The difference is the objective or constraints that we're imposing. So we have 3 ambulances to work with. We're trying to site, and ideally we'd like them to cover all of these 6 sites. But for some reason, we're wanting a very, very quick response time of only 3 minutes. And we already know that you can't cover all 6 landmarks within a 3-minute response time. For example, because Edmund Low, the closest site to it is 5 minutes away. So there's no way we could cover Edmund Low within a 3-minute response time. But you could ask, if we did insist on this 3-minute response time, how many of these 6 landmarks could we cover? So that's that leads us to this max K cover problem. Okay, so K here is 3. So that's how many ambulances we have to work with. The sites are just like before, instead of all I for J and 9 minutes dot keys. Landmarks are the same thing, but the J's. Okay. So now we can define these close sites, just like we did before. So I'll initialize and say that each landmark J is close to nothing. Then I'll loop through landmarks and loop through sites. And if the time in minutes from the site to the landmark is at most 3, then we'll say that they're close. So we'll say that one of the sites close to J is I. Then after we've looped over all choices of I, we can say the close sites to mark are and maybe I'll specify here that this is just 3 minutes. Okay, so it looks like, yeah, Edmund Low, we said that there are no close sites. Hideaway is only close to site 3. So that's 1 minute travel time. Everything else is 4 or more. Seems to check out. Okay, so let's go to our model. Okay, so this particular model, I think we haven't yet discussed in class, but I think it would be okay if we just went over it here. So we have two key decisions, or 2 things that we want to represent in our model. One is that location decision. For each site, we ask, do we locate an ambulance there or not? So that's our area decision. I equals 1 if ambulance is sited at I. And then I also want to have another variable. Okay. So this is going to capture whether or not a landmark is covered. So we'll define this xi, maybe I should say xj variable. This equals 1 if landmark j is covered by a So we'll define this for every landmark, and oops, this will be binary. Okay, so with that variable definition x, it becomes really easy to express our objective. So, and where we're actually maximizing something. And what we're maximizing is the sum of those x variables. So I could just write it like this. Okay, in our constraints, we require that pick k of those y variables for citing ambulances. And then really the only other set of constraints just relates the x variables to the y variables. So normally, like in our set cover problem, we would say that something is at least one for every landmark. So this is essentially the left-hand side would be the number of times that it's covered is at least one for every landmark. But in our particular problem, we're not requiring every landmark to be covered. And so on this right-hand side, we write not one, but xj. So if we say that it's covered, if this x is 1, then it forces it to be covered at least once. If we don't say that it's covered, if this x is 0, then we don't require anything. We require ourselves to cover it potentially 0 times. So the number of times that it's covered would be to say wi, and we'd sum this for I in the close sites of J. Okay. We would go ahead and optimize. All right. So it looks like we're covering 4 sites within that 3-minute response time. Those sites are y variable is selected. So 1, 4, and 5 are the sites. And landmarks that they supposedly cover are J for J and landmarks if the x variable is at least half. So they supposedly cover the airport, Couch Park, Boomer, and the movies. So I think we remember Edmund Low Library was one thing that was not covered, and it doesn't show up here, so that's good. That makes sense. Let's see. So the other one that it's not covering, I think, is Hideaway. So everything except Hideaway and Edmund Low are covered by 145. So remove this column, remove this column. Everything else should be covered by 145. So 1 covers Airport and Boomer. Site 4 covers Couch, and Site 5 covers the movies. So I think that all checks out. I think we're done.